Now that the Alabama senior games have concluded, it's time to get back to backyard science. I purchased this thing. It's to demonstrate that water will seek its own level, so to speak. And it's actually a schematic of the gravity tub, because here's the trash can. Here's the long 1/4-inch tubing out to the clothesline pole. So if this is filled with water, all of these smaller diameter tubes should reflect the same level. So let's convince ourselves that that's true. Try not to spill food coloring all over everything as you pour it into the gravity tub. Should not be doing this one-handed. What a mess. This is where I'm supposed to say something about the progressive pedophilic vampires, but I'm not going to, because that joke got old pretty quick. Okay, so we need some more water. The gravity tub is nearly full of water. Ooh, I thought it was going to fall down. Okay, here you see that the level in the large tub is exactly the same regardless of the diameter of the capillary tubes, especially the thin one. Now, the theory is that if I put extra mass underneath there, that the levels will change. If only I had a ready supply of lead. Oh, but I do have a ready supply of lead. So here I've added quite a bit of mass underneath the gravity tub. And would you look at that? The level at the large tub is already lower than the adjacent one. What if I remove the mass? Still not level. What the heck? Okay, so maybe I don't understand levels after all. Why is that so much lower? Maybe I should give it a chance to come to equilibrium before I conclude anything. But anyway, that's the essence of the gravity tub. Lots of mass underneath here, and the levels should all, well, before the mass, the levels should all agree Then when I add extra mass here, it pulls the level down. And it looks like it's pulling the level down, but I think that's just an optical illusion. Let me clean things up and we'll try it again. Okay, I think I found a contradiction to the law that says water seeks its own level, because the capillary action on the smaller diameter tubes is making the water level progressively higher. So this is not going to be a replica of the gravity tube after all. And also, there's a freaking leak in the tubing. Can you believe that? So yeah, I'm gonna have to repair that. But that's essentially what I've got going on in the backyard. Oh great, I've got a gravity tub and a long 1/4-inch tube going up to the clothesline pole. So if I put mass underneath here, theoretically, it should pull down on the water inside the tub, causing a pressure which will cause this level to increase. So look for that to happen tomorrow when the sun is shining. And in the meantime, water does not always seek its own level. So there. Flat earthers say water seeks its own level. So let's see if we can confirm that. We've got a mechanism here where there's a large diameter tube and a tube running along the bottom, and then tubes with various diameters. So let's see what water will do. I'll add some food coloring to bring out the levels. Then some water. Okay, there's some air in it. I should probably add the water more slowly. But you can easily see that this level is lower than all of the other levels, even though water is supposed to seek its own level. But the whole idea about science is it's got to be repeatable. So let's repeat it. The water in the large diameter tube is there. The water level in the small diameter tube is there. And the smallest diameter, it's here. That looks like it's approximately the same level as that. But none of the levels are the same. This one's all the way to the top because of the capillary action on the small diameter. So yeah, so much for water seeking its own level. We are told by the flat earth community that water seeks its own level, whatever that means. So let's do an experiment. I've got this tubular structure with a large diameter here, a smaller diameter tube running along the bottom in varying degrees of diameter. On the tubes. Instead of talking about level, they should really be talking about forces, because if there were no additional forces, then if I pour water into this tube, it should be level all the way across. But there's an additional force at work, which is the capillary action of the varying diameter tubes. So let's start off by adding some food coloring to help bring out the level. Then we'll slowly add some water. I'll use that as a funnel. I'll use that as a funnel while I'm holding the structure. Okay, I've removed some of the water. So where are our levels at? On the largest diameter, the level is just below the mark. And on this very much smaller diameter tube, the level is above the mark. And the even smaller diameter tube, the level is even higher, with the tiniest tube having a water level almost to the second mark. So you see that the increasingly small diameter tube has greater and greater capillary action. This first level is below the line. The second level is above the first line, although there's a bit of an air pocket right there. The third smallest diameter is even high, the level is even higher. The fourth, even higher. And the fifth, all the way to right there. So yeah, water does not always seek its own level. You have to talk about forces. And in this case, the force due to capillary action is overcoming the tendency of the waters to seek their own level, quote unquote. But the whole idea about science is it's repeatable, so I'm going to repeat the experiment. We're told by the flat earth community that water seeks its own level. They talk about level, but they should be talking about forces. Here I've got a tubular structure with a large diameter tube connected to a smaller diameter tube, and a smaller diameter, and a smaller diameter, and a smaller diameter still. And they're all connected among each other by a tube which runs along the bottom there. So we're going to add some colored water to the structure and see what happens. Well, the first thing we need to do is confirm that the entire unit is level. And I'm going to say that's level enough. I've also got a pair of vice grip or needle nose pliers, giving a little extra stability to the base, because once I start adding water, it's going to become unstable. It's a little misleading because there's uncolored water. So let's drain it and start over.